Hi everyone, this is coming to you from Education for All. Today we're going to look at summation of finite series, not infinite series. We are going to look at summation of finite series. But we are going to apply two different results to solve these problems. We are going to use standard results in one case, and in the other case, we're going to use the method of differences. Summation of finite series using standard results, and summation of finite series using the method of differences. When we say standard results, what are these standard results? These are results, some of them we have proven them during the course. We have proven this one, we have derived this first one you see here. If you are asked to sum up a series of this form, like the summation of the first natural numbers, like this one here, for example, you are asked to add 1 plus 2 plus 3 plus 4 plus 5, say up to 10. It's finite, so you should have an end number here. So if you are asked to add this type of numbers here, the first natural numbers, then you use this formula. That's the standard result. That's what they need. This is the standard formula for finding the summation of the first natural numbers. These natural numbers are counting numbers 1, 2, 3, 4, 5, 6. I made a mistake here. This then should be r square, r square. Right, so that is the case. These are standard results. We don't need to prove anything. If you can remember it, you just use it. Or if you cannot remember it, you should be able to derive it. But once you practice problems in the exercises, these formulas will stick. They will stick. They will stay in your head. You'll be able to retain them for a very long period of time. So the second one, this is summation, again, of finite series using standard results for the the sum of the squares of the first natural numbers. This one, just ordinary numbers. This one here, if you are asked to add 1 squared plus 2 squared plus 3 squared plus 4 squared plus up to 10 squared, this is the formula you use because they are all squared. It has this n over 6 multiplied by n plus 1 multiplied by 2n plus 1. That's the formula. Your n now, it depends to the number of terms. If you are given here r equals to 1 to r equals to 10, so your n here becomes 10. So 10 over 6, 10 plus 1, 2 times 10 plus 1. That is how you go about it. This is the thing, right? So the next one is, this is for the, again, for the cubes, ordinary, squares. This one is for the cubes. If you are given 1 cube plus 2 cube plus 3 cube plus 4 cube plus 10 cube, this is the formula you use. 1/4 n squared multiplied by n plus 1 squared. So now you find out this one is just the square of this one here. The cube is just the square of the ordinary natural numbers. 1/4 is 1 over 2 n squared, n plus 1 squared. So when you square this, You get the cubes. That's why I said you can remember these standard rules, standard formulas. You can easily remember them. And the next one is this, of course, you know it. If you are adding just ordinary number, a constant, sum of a constant, so you just get this function here at the top. For example, if I ask to find r equals 1 to 10 and you put r here, so your answer is, they put 1 here, so your answer is 10 times 1. So that's what you get. If they put 2 here, so your answer is 10 times 2. If you put 3 here, it's 10, this 10 times 3. That's what this formula is saying. More or less, this is n times 1. But any number multiplied by 1 is number itself. That is why you don't see this one here. It simply means n times 1. Right? So this is what you have. Now, having all these formulas, let us solve one problem and see. Let us look for a simple problem first. As we go along, we progress to difficult ones. Here we are given add. Which one? Find r squared. Find r equals 1 to 13. Looking at number 1. R squared. Question number 1. You are find the summation. You are asked to find the summation of this one using the standard forms or the standard results. So this is already r squared. So which formula you're going to use here is this formula here, r squared. This is the one you're going to use. And this one says n upon 6 into n plus 1 into 2n plus 1. But what is our n? Our n is, in this case, is 13. So this means we are going to use this formula here. This gives you 13 all over 6 into 13 plus 1 into 2 times 13 plus 1. So this gives us 13 all over 6 times 14 times 2 times 13, this is 26, plus 1, this is 27. Can we do any cancellation here? Yes. 2 here is 3, 2 here 7. Can 3 go into 27? Yes. 3 here is 1, 3 times 9 is 27. So then we have this multiplication to do. 13 times 7 times 9, which is calculator. Times 7 times 9, it's 19. You get 819. So that's what you get. The answer is 819. Let's look for another one. Now you are given which one here? To be you are given e raised to the 3, number 2. Put it here. R cubed 11/4. R is equals 4 cube is 11. You are asked to find the summation of this one. So, yeah, R cube. Yeah, it's R4. In this instance, as you can clearly see, we didn't start from R equals 1 as in the previous case, our first problem we solved. We started with R equals 1. We start to count from the first element to the 13th element. In this case, we are starting from the 4th element, not the first one. So how do you compensate for this difference? When you have something like this, let me say you are going up to 11. Yeah? You are having 1, 2, 3, 4, 5, 6, 7, up to 11. Yeah? So if we were doing this one, they ask you to find the sum of this series from R equals 1 to 11, then using the standard form, you will just apply this method straight away, this standard form. We just put in this equation here with this. But because you have 4, so what does that tell you? It means they don't start the counting from the first element. They started the counting from the 4th element. From 4 to 11. But you want to use this formula, this standard formula. So which means you need to adjust this one here. That means for us to be able to use this, we have to start our counting from 1 to 11. We start from 1 to 11. But they started from 1 to 4. So which means 1 to 3, we have to take it off because now we have our formula has included from 1 to 11, when of course the question that we are given is started from R4. So which means if we're using this formula 1 to 11, we'll have this summation of R equals 1 to 11, because we want to use this standard form, R cube. What we don't need, we now need to subtract 1 to 3 minus the summation R equals 1, 2, 3, R cube. I hope this is clear because this is the only difficult thing about this, using this standard form. Being able to adjust the index, this index here, or counter, you want to call it. The problem says R4, but our standard form they all start from R1, R1, R1. They count from the first element of the series. So because you are given now your formula, you want to adjust it to start from R1, so you've added 3 elements that were not there. That's why we are subtracting those 3 elements here, 1 to 3, because our formula says now from 1 to 11, not 4 to 11 as we are asked, from 1 to 11, right? R4, 1 to 11. So this is what we will get now, right? We will get this. So this R from 4 to 11, we have adjusted it to mean the same thing as from R to 11 minus R1, from R1 to 11 minus R1 to 3. So once you have this, all you do is just to substitute your formula here, which is 1/4 n cubed. So we have 1/4, the summation of 1/4 n squared, and n squared is 11 squared times 11 squared into 11 plus 1, which is 12 squared for that first one. That is for this first one. We're using this standard formula. Minus now for this second part. You have your R1 again, 1/4 times n squared. Your n squared now is 3. You are now counting from 1 to 3, so your n is 3. So 3 squared, I'll just put it times 3 squared so that you're not confused. 3 squared times n plus 1, which is 3 plus 1, times 4 squared. And you are done. You are done. Once you reach this position, then you just simplify your problem here. Simplify, you finish with this. So let me take off this one. If you simplify, now you're having 1/4 times, you're having 1/4 times 11 squared is 1, 2, 1 times 12 squared is 144 minus 1/4 times 9 times 16. Can we do something here? 2 goes here into 2. 2 here, 7. 2 here is 2. So 2 here, 1. 2 here, 3, 6. Again, 4 here is 1. 4 here is 4. So we're having 121 times 36 minus 9 times 4 minus 36. I want to do something. We have 36, so I will take 36 out. 1 to 1 minus 1. This is equivalent, yeah? You can do your calculator, it depends how you do it. So this is 120. So now I'm getting 120. This is 121 minus 1, so it's 120 times 36. Yeah, so now this is simple now. 12 times 36. Then times 10. 120 times 36. 4,320. 4,320. That is your final answer. And thank you for watching. Bye bye.